Okay guys, in this chapter we're going to be talking about surface area and volume of prisms and cylinders. And so in this first video, just want to start out with a prism. So a prism is an object where you have some polygon. You have two polygons, those are called the bases. Okay, so you have two polygons on the top and the bottom, or they can be on the left and the right. And then there will be lines connecting all of the corresponding vertices. Okay, so here's a corresponding vertice, here's a corresponding vertice, etc. So then what you have then is you have two bases, and then you have a group of faces, which depending on the shape, you know, this is a hexagonal prism. So a hexagonal prism has 6 faces. So I just want to talk about the anatomy, sort of the parts of a prism, and then we're going to get into sort of the formulas for surface area and volume. So looking at this picture then, we see there's two types of prisms basically. We have, the most common is a right prism, and this is probably what you're most used to. Okay, we also have an oblique prism, which is the same thing. We still have two, again, going back to the definition, we have two bases that are polygons, and then the corresponding vertices are connected with a line. The only difference is that that's not at a 90-degree angle there. So with the right prism, we have, again, we have the bases are the top and bottom. Same thing with the oblique prism. The top and the bottom are the bases. Okay, we have the faces. Okay, so the lateral faces. We have the edge up here. We have the lateral edge. So all of these in any three-dimensional object, a line that connects two planes is called an edge. So we have the lateral edges. That's also called the altitude or the height. Okay, and then finally we have a base edge. So lateral edge, base edge. They're just edges that are either connecting to a base to a face, or two face sort of planes together. So in the oblique, let's see, the oblique prism down here, we have a lot of the same thing, all the same features. The only difference is that, and when we get to the formulas in a moment, you're going to have to take into account the height. Okay, the height of this is not going to be, it's not going to be the slant height here. Rather, it's going to be the right angle. You know, height is what we take from a perpendicular, you know, an altitude is where we take from here to a line perpendicular. So we have to create kind of a right triangle. So whenever we're dealing with oblique prisms, we have to take that into account. So let's go ahead and go to this next picture here. Now what I want to sort of start out with, we have a hexagonal prism here, and I just want to talk about what the formulas for a prism are, surface area and volume. Now this is a hexagon, but of course we can have a triangular prism, rectangular or quadrilateral prism, we can have pentagonal, hexagonal, octagonal. Any sort of polygon can make up the base. So first I want to talk about surface area. All right, so surface area I think is the simplest. Okay, surface area. Of course, there, you know, the surface area is the area that all the surfaces take up. In other words, it's all the faces. Okay, and then it's the two bases. Okay, so the faces, this part, a lot of these days, a lot of books and maybe your teacher, they focus on something called lateral area. Lateral area. So lateral area. And if you've done this in school, you probably have heard of lateral area. Lateral area is going to be the area of all of these faces. Okay? In other words, it's going to be the area of some amount of rectangles. Okay? Well, how do we find what the, you know, if we want to add up, in this case there are 6 rectangles, how do we add up the 6 rectangles around here? Well, we know that the area of a rectangle is length times width, so we have sort of, or we have base times height, you could say. But here we have the width and the length. Okay, here we have the width and the length. And so we can go around, and basically if you take the width, the width, the width, the width, all the way around, okay, so if you take all those widths, that's going to be the perimeter, right? And if you multiply that by the height, then that'll be the lateral area. So the lateral area is the perimeter times height. So again, this is what is sometimes called lateral area. So that's the area of the faces. And then you have to add on 2 times the area of the bases. Okay? So we have this lateral area here, and then you have to add on 2 times the area of the bases. Okay? So again, this again you might have seen is called lateral area. Okay, now I want to get into the volume, which is slightly slightly more conceptual. So the volume, before we get started, I want to just paint a picture, well, not literally paint a picture, but I want to illustrate the idea of where this volume comes from. So our base for the volume is going to be a cube. Okay, so imagine we have a cube with dimensions 1, 1, and 1. Then by definition, the volume of this cube is 1 times 1 times 1, which is 1. Okay, now let's say we have another, not cube this time, but let's say we have a rectangular prism. Okay, so my drawing's not the best here. But imagine that this is 3 by 2 by 2. Okay, and the question is going to be how many units are in that? How many units are in that? Okay, well, we can divide this up. So you can always refer back to this. All right, well, we can divide this up, no problem. Okay, so the question is how many blocks are there? And you can see, that's not a very good line there. Okay, so there's 2. All right, so how many blocks are going to be there? Well, it looks like there's going to be 4, and then 4, and then 4. Well, 4 times 4 times 4 is, 4 plus 4 plus 4 is 12. So there's going to be 12 blocks. Another way you could get that, of course, is to multiply 3 times 2 times 2. So that's what you're most used to, and this is how we're going to visualize rectangular pyramids. But here we have a pentagonal pyramid, and what I want you to first think about is, let's say, we have a hexagonal pyramid. Let's say the height, in this case, I'm just doing any polygon. This is a hexagon, so I'll do a pentagon here. But let's say the height of this is 1. Okay, so the height is 1. And then let's say, for example, that the area of this base, so the base area equals, let's say, 5. Okay, so let's say the base area equals 5. Then in this case, for example, our height is 9. So let's say I drew another one of these. Again, I'm going to use a pentagon because we have a hexagon here. Okay, so let's say we have this. Okay, we're going to come down. All right. So we've got that. Okay. So again, we're going to use the same type of logic that we use with rectangular prisms. Okay, imagine this is this time, let's say 4. And again, let's say the base is going to be 5. Okay, so the base equals 5. So this area, this volume, because the height is 1, this is 5, then that's a 5 chunk, that's a 5 unit volume, so our volume would just be 5, right? But in this case, let's say we have 4 of these, right? So we have 1, 2, 3, 4, okay. So again, using the same kind of logic, then you can see I'm not going to draw all the way around, but we have little slices. The top one is 5, the second one is 5, the third one is 5, the fourth one is 5. And so basically what we can do then is if we split these up into units, whether it be with a polygon or a cube, then we can always split these up into units. And what you're going to get for the area of the volume is going to be area of the base times the height. So you find the area of the base, and then if you multiply that by however tall it is, then that's going to give you all of these cross sections and these chunks that you can pull out. Okay, so it looks like this with a rectangular prism. It looks like this with a polygon. Okay, so whether it's a pentagon, hexagon, octagon. Here we have a hexagon. So again, if I want to figure out the area and the volume of this, okay, let's go over here. So we have the surface area here. Let's see, surface area equals pH plus 2b. Okay, so pH plus 2b. Well, what's my perimeter here? Okay, my perimeter, it looks like the side lengths are 3. Okay, so we have equals 3 times 6, so that's my perimeter. Okay, my height is 9, plus 2 times the area of the base. Well, what's the area of the base? The area of the base is 1/2 AP. So this equals 3 times 6 is 18. 18 times 9 is 162 plus AP, because the 2 and the 1 cancel out. So what's A, what's P? Well, I'm going to go over here to figure that out. We have to use a right triangle. So if we look here, we see that this is 3, okay, and we have to make a right triangle here, because this 6 is the radius, right? So that's the radius. So we have to make a triangle here to here to here, okay? So make a right triangle right there. Let me draw that down here. Again, we have a triangle. Right triangle looks something like this. Okay, so here we have 1.5. Here we have the apothem. Here we have the radius, which is 6 in our case. Okay. So we have to do Pythagorean theorem. A squared plus, I'm going to convert this to 3 over 2. So 3 over 2 squared is 9/4 equals 36. So A squared plus 9/4 equals 144 fourths. So A squared equals, it looks like 135 fourths. So A, if you take a root of that, the top can be reduced to 3 root 15. 3 root 15 over 2. So that's our apothem. Okay. So let's go back here. We have apothem is 3 root 15 over 2. So 3 root 15 over 2 times perimeter. Well, the perimeter is going to be 18, right? Times the perimeter, which is right here, is 18. So this is looking a little bit ugly, but that's okay. 162. And this is going to be 27 plus 27. So I got that because this is 1 and 9. So I made this a 1 and this a 9. 9 times 3 is 27 root 15. That's going to be units squared. Okay. The volume, on the other hand, is a little bit simpler. Area of the base times height, okay, which equals 1/2 APH. Okay, so let's plug in those numbers. 1/2. Apothem, again, is 3 root 15 over 2. So times 3 root 15 over 2. Times the perimeter is 18. Times the height is 9. Okay. So here we have, this is 1/4. Okay. Let's see. This is 1/4. Let me just do this one at a time. So here we have 2. This becomes 9. Okay. Here we have 9 times 9 is 81. 81 times 3. So 81 times 3 is going to be 243 root 15 over 2 units cubed. Okay. Hopefully this gave you a decent idea of what a sample problem looks like and where the surface area and volume equations came from for prisms. Thanks for watching.